Welcome back, viewers. Let's continue this episode number 8 on the tutorial on what? Permutation. We have two questions to solve based on the concept of permutation. 7 athletes are participating in a race. So, in how many ways can the first 3 prizes be won? Remember, permutation is just arrangement. What are we arranging? We are having 7 different athletes to arrange. The prizes to win is 3. So 7 different objects, picking 3 at a time. So that simply means that I am dealing with 7 permutation what? 3. And what does it say? 7 permutation 3 means 7 factorial divided by 7 minus 3 all factorial, which becomes 7 factorial on what? 4 factorial, right? 7 minus 3 is 4. Now, remember what we say about factorial. Factorial is just multiplying the integer by non-negative values which are less than that integer. So, 5, 4 factorial, meaning 4 also continues, divided by 4 factorial. I am having 4 factorial here, hence I leave this one in 4 factorial. This simply means that I should be having 7 times 6 times what? 5. And in the case of this, I should have 30. 30 times this will give us 210 what? Ways. So 210 different ways by which we can be able to arrange the 7 athletes whereby the first 3 prizes will be won. Alright, then let's look at the second one. How many numbers between 400 and 1000 can be made with the digit 2, 3, 4, 5, 6, and 0? How many digits? Don't forget, between 400 and 1000, let's see. Between 400 and 1000, how many digits can we form? I can have 401, which will be 3 digits. I can have 500, 569. They are all going to be 3 digits. So I should be considering only 3 digits. There are 3 digits I'll be forming. So it could be 2, 3, 4. But 2, 3, 4 will be 234, which is not between 400. So it means that 2 cannot start this 3-digit number I'm looking for. 3, 4, 5 will be 345, less than 400. So it means 3 can also not start. But 4, 5, 6, 456, 4, 2, 3, 423, they are all between these. So it means that for our digit, the first digit, can only be 4, 5, and 6. Don't forget, even 0 cannot come. 4, 5, and 6. That's the first digit. So this first digit is secured. The position of first digit is secured. How many ways can that be arranged? That could be arranged in 1, 2, 3. 3 ways. So I can say that will be 3 ways. And that 3 ways will multiply the remaining 2 positions. There are 3 digits. I've taken the first digit, so I'm left with 2. Imagine the number is 423. I've taken 4, so I'll be left with 2 and 3. So I'm left with 2 digits to be selected. And these 2 digits to be selected from how many different digits do we have? We have 1, 2, 3, 4, 5, 6. 6 digits. But one of them has already been selected here. Even though there are 3 ways to select this, it is not all the 3 of them will be placed here. So imagine the first digit in this number is going to be 5. If it is 5, I'll be left with 1, 2, 3, 4, 5. There are 5 digits again to select from. So it means I have 5 digits selecting only what? 2. That is 5 permutation 2. This 3 is having a restriction. There's a restriction on the numbers, which simply means that in how many ways can we arrange this number to get 3-digit numbers, whereby the first digits will be between 1, 2, 3. There's a restriction. Alright, so this will be giving us 3 times. In the case of this, let me just say I have 5 factorial on 5 minus 2 all factorial. What will it be? It will still be 3 times 5 factorial on 3 factorial. That is this minus this is 3. So I still have my 5 times, okay, before then, this will be 3. 3 times 5, 4, 3 factorial, 3 factorial. This is 3 factorial, so I don't need to expand this to the fullest. 3 factorial will cancel 3 factorial. I should be left with only 4 times, 5 times 4. That will be 20 times 3. That will give us what? 60 ways. So it means there are 60 different numbers, 3-digit numbers that can be formed between 400 and 1000. 60 different of them, provided the first digit will only be 1, 2, 3. I guess this is also clear. Don't forget to share with somebody, like the video, leave a comment behind for us to be part of the family. Subscribe if you have not. Bye-bye.